Hi everyone. This is day 6 and it's Monday and we're finishing up the unit, so there's quite a bit of information or data or material here that I'm going to cover. The date here is 1/30/17 and this, if you're curious, is week 3 and we are finishing up unit 1. So we need to get started. The first thing I want to do is talk about value of a network, and we're talking about all kinds of networks, and I'll emphasize that in a little bit. Everything from getting value of connecting things by the cloud or setting things up on a local area network. Okay, so what I feel is the most important thing is what we share, and that's data converted to information. Typically the data is stored, and from the data we get information. We take software, manages data, and gets information. We'll talk about that in a little bit. But if you just think about all the things, if we were going to refer to a cloud environment, everything you buy, sell, keep, how you get paid, and we listed just a number of things in class. Okay? Most important, sharing data converted into information. You can also share hardware. You can have one printer connected to our local area network. In fact, a lot of people nowadays, they just have a printer in their house, that's the way we have it, and it's connected to our Wi-Fi. So we don't have to have wires or anything running to it, and any computer in the house can print via Wi-Fi to that printer. You can also share storage. You could actually, have a hard drive connected to your network in your house, not very expensive, using USB, and you can storage that way, and you could share that storage, or you could use that for backup, or you can share storage on one particular computer on the hard drive where lots of people can access it. Now on local area networks, that's done a lot. We have a similar place where people can store their files, and using the network they can access those and get them off. We can also share on a network software. Now you need to be a little careful, when you buy software, typically you're buying a license to the software. Seldom do people actually own the software they buy. They usually get a license, okay? Now you can distribute that software via your network if your license allows you to do that. Another option to that is open source. You can have software in which the source is open, so you can distribute as many copies as you want via your network. Alright, let's keep moving pages we're going to go through today. So carrying over those ideas of what we have on the network, you can store data on a network, and you can store program files via the network or storage on some type of storage device. Okay? So, for example, you could have a data server, or you can have storage and have an app server where you can get the server. Sort of like what you do with Google when you use Google Docs or Google Sheets and so forth, Google Docs in general. The apps sit out the website and you use a browser, let's say from your home, to access them. On a local network, could that be? Or you can have your PC and you can have your apps stored right on your PC. A lot of apps are stored right in your phone too. Okay? But what you're storing typically is one of two things. It's either the data that the app's going to manipulate, or it's the actual app itself. At first, some people get confused on how that works, but it's important to understand that. And we're going to talk a little more about it here. Those program files could be stored local, right on your device or machine, or you can get them off a local area network, or you can get them from the cloud like I showed with Google. How we organize those, we organize them in folders and or directories. Linux operating system typically uses the word directories. Folders is more of a window or a GUI representation of dividing up file names so you can find and access your files. Okay, so let's move back up here to program instructions. Software manipulates a data file, list of instructions called an application, usually has an extension of exe, which means executable. Data files typically have an extension 3 or 4 characters, like docx is a Microsoft Word file because of the X. So we have WAV files, the MP4, we have picture type files. There are literally hundreds and hundreds of extensions that represent different types of files. Talk a little bit more about that later. Alright, we just went over all these options to store files. What happens is that data storage goes bad for your files. Well, you need to have a backup, or at least, at the very least, you need to have some kind of backup plan for important files you don't want to lose, whether it's on your laptop, your PC, or whatever device you may have. So we're going to talk a little bit more. So, which files are important that you need to back up, where are you going to back them up, and when. Okay? So, people don't necessarily back up their entire devices, but if they have important files on them, they want to back them up. Now, one of the more logical ways to do that nowadays is if I have a PC at home and I want to back my files up, I can take a copy of those files and I can have this done automatically, and it can put it on my Google storage. Or I also use Dropbox. So I'll take important files either when I'm here at the college, and I can take them and put them on Dropbox. They have lots of storage available if you want to pay for it. And they have a minimal amount that you might be able to build on in your Dropbox. I can be at home and I can take files and I can put them on my Dropbox. And then the company, Dropbox, they back up their files somewheres off-site, so if something happened to these, they would be able to restore it. Now you can take, from your home, you can take your files and store them on a portable hard drive device and then store that like in a safe, so if there's a fire, it doesn't get destroyed, or at another location. All businesses and so forth figure out ways to back up files. Another simple example, I'll give you one more example. When I plug in my Android phone to charge it at night, it automatically backs up all my picture files out to Google. And those are the only ones I really need to save off my phone, my photos and videos. And it does it automatically, so they're all stored out here if I ever need them. And then Google, they manage backing those up on a regular basis too. Okay. We'll talk a little more about the cloud environment here, but you can see up here we listed NIACC. Here's the IT department, PC 229, where we have class, and we have access into the internet through an internet service provider. And the college actually has 2 connections in, and they pay for that by how much bandwidth that they have available. And so sometimes I'll draw that like a pipe. How big is the pipe? Okay? So, most of the time then, your ISP, how do you pay? You typically pay for bits per second. The number you hear is usually how many bits down, which means how many bits per second can move from the internet into your location. Now the up amount is usually less on a typical ISP that we as clients use. If you don't, like we don't, I don't house a server here, so I don't need a lot of bandwidth going out, because I usually send a small request out and get a big request coming in. Okay? Now, sites like Airbnb or Uber or Wikipedia, or over here I had Google and Facebook, they got to have big pipes going in and out. So theirs, they will pay more to have lots of space to send information in and out, so people don't get bottled up and can't get to the information they need. Those would be the servers. And what do they hold? All kinds of things. Google holds apps, place to store stuff, a place to use search to find stuff. Airbnb, they have servers that store houses that can be rented, so people can come in and add their house to be rented. People can come in and rent a house, and they just manage that and get a percentage of that information. Okay? So all this traffic. We talk more specifically about networks. Next unit we talk a lot about the internet, and then we talk about how networks work after spring break. Alright. More information. We already talked about hardware. We talked about, in there somewhere is a processor that does all the work, and tied with a processor can be cache memory, high speed area, where the processor keeps things it's going to use most often. It's like that immediate memory that you keep in your head. Then we have RAM, random access memory, the main memory of the computer, and here is where all the work occurs. Instructions are in there. The instructions go to the processor processes them and sends the results back. And during that, if need be, it could send information out to display, it could possibly store something on the hard drive, it could communicate to USB, and it could communicate to keyboard and a mouse. All those type of things. I like to use the word storage for permanent storage. Here I'm referring to, let's say, hard drive, or another way to store is this technology called flash. And we'll talk more about those specifically in Unit 3. We mentioned the ports, USB, keyboard, display, network port, very important. Allows your device to connect to a network, and that could be a wire, or it could be Wi-Fi, and there's a few other options. But those would be the two most used. Smart devices, smartphones would use Wi-Fi all the time. Laptops could use wire or Wi-Fi. What communicates now, what communicates to the hardware is the operating system. For example, Windows, made by Microsoft, they're up to Windows 10 now. Linux, Unix are operating systems. These happen to be open source. There's for the Macintosh, there's a Macintosh OS. They don't call it MOS, but Macintosh OS, I guess I should say this, Mac OS, which nowadays looks very much like this, like Unix. And then we have operating systems for our smart devices. We have, that's a little I, OS for the Apple, and we have Android for smartphones, and then there's some other ones. BlackBerry has their own, Microsoft actually has their own, and so forth, for phones and or tablets. So all of these communicate with the hardware. Tell the hardware what to do, that make sense? All of them communicate back and forth. What communicates with the operating system are the applications. All of the apps that are on your devices, they communicate. So apps on a Samsung phone that uses Android would communicate to here. Apps on an Apple phone would communicate to this operating system. So the app has to be designed to match the OS. So the same thing's true even apps down here. If you have an application that runs on Windows, it would have to be an adjustment to make it run on Linux, or an adjustment to make it run on a Mac. Who communicates with the apps? The user. And in a lot of cases nowadays, the users don't know anything more than how to click an app and watch it work. Now, operating systems, applications, operating systems comes from what we call system software, which includes the operating systems. We got a bunch of examples up here. Or utilities, like when you look at files and folders with Windows, you create new directories, and then we're going to look at some other utilities. Virus software could be considered a utility. Applications are what we use. This is what the users are most used to using. Man, almost done. But this is a good section. Let me review a couple key things on Unit 1. We should be able to distinguish the actual hardware devices, like the difference between when somebody uses the word Samsung, they're typically talking about the Samsung physical phone, smartphone, or the Apple iPhone, they're typically talking about the Apple iPhone. Of course, Samsung makes TVs and lots of other things. And then, so hardware, we have all kinds of devices, but nowadays, typically it's phones, laptops, or what a lot of people are used to, and simple PCs. All this hardware, then, is designed to only talk to the operating system. And so, those operating systems that we listed actually are what communicate with the hardware. Now we can do things like use a utility to go in and add folders and so forth to a piece of hardware like a hard drive. Okay? Now, what communicates to the operating system? Some kind of software called an application. Now, examples that we use: browsers, maybe an email client, and then word processing, spreadsheets, maybe simple databases, maybe something to watch videos, maybe a piece of software to record, to create either videos or audio, or all of these things we do on our devices and our computers, typically then our apps. They talk, this is really important, they talk to the operating system. That's why an app that works on Windows will not work on Linux directly. Something might have to be changed. Who talks to the apps? User. The easier we make the app, typically the less the user will know about everything else. And in this course, we want to take experts are also users, but they know a little bit more about the operating system, and they also know a little more about the hardware, which makes them better understand how this might affect the world. Getting kind of broad-minded there, but anyway. So, you should now have an understanding, and you can check the objectives and the essential questions at the beginning of Unit 1. You should have an idea what hardware is, and then a little bit about all of this software that talks to the hardware. That's it. Unit 2 coming up.